Hello Year 10. Today's lesson is going to be properties of waves. I literally just recorded this lesson, but my microphone was muted, so I wasted 15 minutes of my life. Now I'm going to do it again, and this time I've double checked I am absolutely recording sound. Today's lesson folder is in here. Now before we start, I'm going to explain the tasks. This is the work PowerPoint, so I'll open that and I'm going to minimize it. Now at one point you will have to label a wave in the PowerPoint. It will be on the PowerPoint, but if it's too small or you'd prefer to have it on a separate document, here it is. Now the first task that you will be doing is a Quiziz task. You just have to follow this link here, and what will happen is this will open. You will be given a name. Well, you give yourself a name. You click go, and then you start the game, and it'll be like a little quiz. You'll be given questions. You have to choose the answer. The timer ticks down. You see at the top there. At the end, there'll be a leaderboard. You can see how well you did compared to everybody else. So that'll be task number 1. Task number 2, you've got a bronze, a silver, or a gold task. Okay. Now, the bronze task, pick 3 or 4 calculations to do. The first box is easier, the second box gets more difficult, and so on. Okay, they give you the equations to use. The second task is a silver task. There's a table to fill in, but there is more rearrangement to do. So most of the stuff is filled in. You have to use the equations you are given to calculate them and fill in the blanks. And the gold one is similar to the silver, but a little bit more complicated, because you have to contend with prefixes. Now the answers are there for the gold one, so please have a go first before you check your answers. Last task. You do not have to write on this sheet because it is a PDF, and I know you can't edit PDFs and it's annoying. Let me zoom out a bit. Why is it not? There we go. Now, what I want you to do is I want you to read through and in your mind try and fill in the blanks, okay? Once you've done that, check it with the summary answers. And as you can see, I didn't write this. Someone with neat handwriting did it. So check the answers. If you read one of them and you really don't understand why that's the answer, you need to check the notes. You need to check that document, the Word document I gave you last lesson, which was the document with like wave speed and the wave diagrams on and the labels. And then if you're still stuck, you need to come and ask me. Now, let's get on with the PowerPoint. So today we're doing kinds of waves, and we'll do a quick recap of what we did last lesson. You will need a calculator, so you could use the calculator app on whatever you're using, or an actual calculator, which is what I've got. Now, Mexican wave, is it transverse or longitudinal? So pause, have a little think. Maybe you can Google it, watch a video, and then come back to me. Hopefully you've had a look. Mexican wave is a transverse wave. Now, so the easiest way, if it's got an S in, if it looks like an S, you've got a transverse wave. So if I drew a wave like that, okay, it kind of looks a bit like an S, but sideways. That's a transverse wave. Now, if you look at the Mexican wave, you've got people, haven't you? What happens is some of them stand up, okay, and then sit back down, right? So the wave travels that way, right? But that person has only gone up and then back down. So the Mexican wave is transverse. The wave is moving to the right. The people only move up and down. So they are moving at 90 degrees to the direction of the wave. Now, these words, we need to absolutely know what these mean. The two most important ones being wavelength and amplitude. Okay? Wavelength is a distance of one complete wave. The easiest way to measure that is go from one peak to the next peak. Okay? A wave direction, that's straightforward enough. Which direction is the wave going in? You need to know this because then it helps you identify whether it's a transverse or a longitudinal wave. The peak is the top of the wave. The trough is the lowest point of the wave. And the amplitude is the height of the peak from the middle, or the depth of the trough from the middle. It will be the same thing. Now, using this diagram, I would like you to pause and I would like you to label it. Okay, so try and match up in your head. If you just want to go back to this slide and then label it A, B, C, D, E, whatever. But somewhere you need to write down what you think A is, what you think B is. So maybe you could open a Word document, A equals this. Once you're done, resume it, and then I'll give you the answers. Right, assuming you have done the answers, that is a peak. It's the top of the wave. So E is then, I'm going to just do a line here. E is a trough. C is the wave direction. Now, B is the wavelength. It is the length of one complete wave. I said do it from a peak to a peak, which would work as well. If I did it from that peak to there, if I did this instead, you would find that it is exactly the same. So B would also be that, right? Now, but if I test here, B, the measurement starts there and it goes through a peak, back to the center, through a trough, and back to the center. Okay, that is one complete wave. Now the last one, D, this is the amplitude. Now notice, if I draw a wave over here like this, the biggest mistake people do is they go, right, let's measure from here to here. That is my amplitude. That is wrong, okay? Right, what happens is when I've got a wave like this, you should always cut it through the middle. The reason for this is, let's say this is the water wave. The water's resting on the lake. Just imagine there's no ripples at all. That's where it's resting. I chuck a stone in the pond and it causes a ripple. What happens is that water particle will move up, back to the center, and back down. Then back up to the peak, down to the center, and back down to the trough. And that is why you measure it from the half point. Okay? So the peak is from the halfway line up to a, sorry, the amplitude is from a halfway line up to a peak or down to a trough, whichever is easiest to measure. Now, this top equation you absolutely have to learn. I'm going to write it again here. V equals F times lambda. So that upside down Y is called lambda. It's a Greek letter. BDA. It just means wavelength. Now, this equation here you will be given on your equation sheet. Okay, so this will be given. This equation here will be a mixture. You need to learn the top one, but if you substitute in equation 2, right? If you get equation 1 and substitute in equation 2, you get equation 3. You don't need to do that. You can do it one step at a time. But absolutely, you need to write down the top equation and the second equation. Now, what is a frequency? Well, a frequency is how many times that wave oscillates per second. The last lesson we talked about, you can calculate the frequency as how many times does a wave pass a certain point every second, when we were talking about the ripple tank. Okay? What you are essentially doing is counting how many times does that wave oscillate every second. Okay, so if I had 5 waves in a second, my frequency would be 5 Hertz. Now, get your calculator out, have a go at these. And once you're ready, unpause the video. Hopefully, we're ready to go, and we wrote V equals wave speed equals frequency times wavelength. And we said, well, that is the frequency, that is the wavelength, 5 times 2, 10 meters per second. Job's a good one. Next question. Pause it, have a go, and pause when you're ready. Again, hopefully we wrote wave speed equals frequency times wavelength. But what we might have noticed that is not in meters. Okay. Very specifically, you need to make sure this is in hertz and not, say, megahertz or something like that. Convert it to hertz first. This needs to be in meters and not, say, centimeters or kilometers. Right? Then, once you've done that, you'll have 50 for the frequency times by 0.2 for the wavelength, which gives you 10 meters per second. Now, if you're given a wave diagram like this, this could be a longitudinal wave. This could be a transverse wave seen from the top. It doesn't matter. If you're given this, you measure from either a compression to a compression or a peak to a peak. So this is the wavelength, right? Essentially, you find the same spot on the next wave and you measure that. So if you were doing a practical like this, you could even say put your ruler like that in the middle and take a photo, and then you can measure exactly how long that wavelength is. Next one, again, this is recap from last lesson when we looked a little bit at the required practical and the water bath with the vibrations on. Ripple tank it's called. Now what you do here, remember, you could calculate how many waves pass this point in 1 second, or you could count how many waves pass in 30 seconds and divide it by that number. So let's say I did it for 60 seconds. Let's say in 60 seconds I get 120 waves passed. Well, that means every 1 second I get 2 waves passed. That means my frequency is 2 hertz. 2 hertz is saying every second I get 2 waves go past this line. Wave speed, we know what the speed is. A wave speed is just how fast is that wave traveling. Now, you don't have to do this. So go to the quizzes now, that quizzes link, this is task 1, and do that quiz and then come back here. So pause the video now and come back once you're done. Right. So hopefully you've done the quiz, you've had a look at how well you did, and you realise where you made your mistakes. I'm just going to quickly do these. What is the distance between 2 peaks of a wave? That is the wavelength. Question 2. If the wave speed remains constant and you increase the frequency, the wavelength will decrease. Question 3. If the wave speed remains constant and you decrease the wavelength, the frequency will increase. A higher frequency and a smaller wavelength mean more energy. Generally, a more dangerous wave. So, 2 water waves hit the beach every second. They have a wavelength of 15 meters. So, wave speed equals frequency times wavelength. 2 water waves every second. That's a frequency of 2 times 1.5. Okay, so the wave speed is 3 meters per second. Question 5. A wave has a frequency of 5 hertz and a wave speed of 15 meters per second. So wave speed equals frequency times wavelength. Frequency is 5. Wave speed is 15. So what do? We need wavelength by itself. So we have to get rid of the 5, divide both sides by 5. You get 3 equals the wavelength, and that's 3 meters. Now, last thing you need to do, complete your bronze, silver or gold task, and then complete task 3, which is the summary, and then send me your task 2 in, because your task 1 will be online. Your task 3, remember, you're just reading it and you're looking through and filling in the blanks. So send me a task 2, please. And then you are done.